And then for C, we do the same thing that we did in B, where we want to set up this 1 over 3 minus x in the orientation of 1 over 1 minus r, so we can put it into the geometric series form. And so what we do is forcefully factor out 1/3 and then make that the, oh, this is wrong actually. It should be 1/3 times 1 over, and then what we're gonna do is pull out the 1/3, and then now we have our equation set up, now we have our equation set up like the geometric series right here, so we can put it into that form. And then we have to pull out the coefficient of the 1/3, and then same idea where we multiply in the 1/3, and then since we have 3 times 3 to the n, that's gonna, with the same exponent rule, turns into 3n plus 1, and then x to the n stays x to the n on the top because it's multiplied by 1. Then we take the absolute value, since the absolute value of r is equal to x over 3, we put it in this inequality right here, and then we multiply by 3 on all sides, and then we get the endpoints, and then we test the endpoints, and we end up getting -1 to the n, which diverges by geometric series test, same as the previous example, and 1 to the n, which also diverges by a geometric series test, same as the previous example. So we put parentheses around the interval of convergence from -3 to 3, and then using all the answers from all the different parts to express g of x as a power series and find the interval of convergence. So we figured out that 1 over x plus 2, when expressed as a power series, is this equation right here, is this series. And then since we have a 1/5 in the numerator, we just multiply 1/5 into the equation, and then we get this as our value for 1 over x plus 2. And then same thing, we already figured out in the previous example how to represent this as a power series, and then we multiply in the 1/5, and then we get this as our values. And so then if we add them together, just the two series that we got right here added together, and then if you'll notice that the interval of convergence on the 1 over 3 minus x is -3 to 3, and the interval of convergence on this one is -2 to 2. So where they overlap is the interval of convergence for this series, which is between -2 and 2, because that is included in both of them. And then now that we have to express 1 over x plus 2 as a power series centered at c equals 2, determine the interval of convergence. So we have to put it in this form because, in the form x minus c from where the center is. And since the center is at 2, the c value is going to be 2. But then we have to make it equivalent to what the original equation is. So we have to add this 4 so that it ends up being equal to, because x minus 2 plus 4 is equal to x plus 2, so it'd be equivalent to this. And then we factor out a 4 so that we have it in the form that we want. Then we pull out the coefficient, and then since it's going to be a negative value, because 1 over 1 minus r, it's a negative value, you have to make this a negative value, and that is our r value. Here I've just simplified it to turn it and to show what it would look like as the power series. And then when we look at the geometric series, this is our delta r, or not our delta, our absolute value of r right here. And so we're going to put that in the inequality, set it between 1 and -1 to find the interval of convergence. And then we multiply by 4 on all sides, and then we add 2 on all sides, so the endpoints are -2 and 6. We test -2, results in having 1 to the n, so we know that it diverges by geometric series test at this endpoint, so we're going to use a parenthesis. And then we test when x equals 6, and we plug it in, ends up diverging by geometric series test because absolute value of r is equal to 1, so that means it diverges. And then so put a parenthesis there, so the interval of convergence is parenthesis -2 comma 6 parenthesis. And then one thing I noticed that I did incorrectly now that I'm looking back over it is that I did not take the absolute value of r right here when calculating the endpoints, but it didn't really end up mattering all that much because you get the same inequality in the end in the same solution. But that's it.